Okay, last week we looked at finding the gradient. We started with how to find it, or how you were expected to find it in Year 7 and Year 8, which we'll have a look at again in the PowerPoint. And then we moved on to how to find it in Year 9. So the learning objectives are to be able to state the gradient within the general equation, and the general equation is in the form y equals mx plus c. Sometimes that c is a different letter, but ultimately it is the same thing. It's just the y-intercept, and this m represents our gradient. Okay, so we needed to be able to find the gradient in an equation. We also needed to be able to calculate the gradient from a line using 2 points, and to determine the rule using 2 points and the y-intercept. So what we ended up is to calculate it using this, using a graph. So the gradient is always m, that's how steep the line is, and we can find that by doing rise over run, and that was the equation that you will have used in Year 8, where you just counted how far you went up or down, depending on what the equation did, and how far across. The c, or the y-intercept, is your c, your plus or minus, depending on whether it's below 0 or above 0. So we're going to do a couple of examples using the Year 8 method for finding the equation or solving the equation. And we can also do that via substitution. We're not going to look at substitution today. I'll do that in another video later on. So to find the rule from a table of values, what you do is we need to recognize that that your run is your change in x, and your rise is your change in y. And we need to make sure that those steps are the same for each jump as such. So for this one, we're going up by 1, so it's plus 1 each time. And it's consistent across the table. For our rise, we're going up by 3 each time. 10 plus 3 is negative 10 plus 3 is negative 7. Negative 7 plus 3 is negative 4. Negative 4 plus 3 is negative 1. And negative 1 plus 3 is 2. So our rise is going to be, or our gradient is going to be 3 over 1, or just 3. It's sometimes helpful to leave it as a fraction, just because it makes it easier to graph later on. The other way of doing it is to look on a straight line, okay, and work out how many up you go for how many across. So in this one, it is going to be a positive because we are going up, and we've talked about positive and negative gradients. So for every 2 that we go up, we go across 1. So our rise is equal to positive 2, and our run is equal to 1. Therefore, the gradient is equal to 2 on 1, or 2. Now, to start with our Year 9 content. So we need to be able to use 2 points on a line, or 2 points that are given to us. If they're given to us on a line, we just find them, we use them. Remembering, and this seemed to be a problem that a number of people were having the other day, is that x always comes before y. So it's a good way of remembering in terms of babies crawl horizontally before they learn to climb upwards. So x, then y. Your rise, again, we talked about it just before as being a difference in or how far you go up or down, depending on which direction the line is going, divided by how much you go across. So we've got two different examples here, and it doesn't matter which one you call x, y1 or 0.1, 0.2, because it will work out in the end. As you get more comfortable with it, you'll know to recognize to do it based on whether or not you'll get a negative number out of it. So this is going to be x1 and this is going to be y1, and this is going to be x2 and this is going to be y2. Now a few people got confused the other day about these little numbers here. They're called subscript, and it's just to indicate which we're essentially naming the coordinate here. So y2 is equal to 9. So we're going to use the equation m equals y2 minus y1 over x2 minus y1, and that negative just means it's a difference between 2 points. So what is the difference between 9 and 3, and what is the difference between 5 and 4? We're going to find that out by substituting in. So y2 is equal to 9, y1 is equal to 3, x2 is equal to 5, x1 is equal to 1. We work it out. So 9 take away 3 is 6. 5 take away 1 is 4. So we end up with a gradient, and remembering to simplify, so the same rules apply, 3 over 2. Again, we're going to do the next one the same way. Pause this, rewind it, whatever you need to do in order to remember it. So again, doesn't matter which one's which, 0.1, 0.2. What does that mean? Well, that means that this is x1, this is y1, this is x2, this is y2. Put it into our equation. M equals y2, that's going to be the negative 4, minus y1 divided by x2 minus x1. Substitute in y2, negative 4, minus 6 over 7 minus 2, which gives us negative 10 over 5, and our answer is negative 2. That'll mean that your line, when we start sketching, will go down. Okay, so we'll pause it there if you need to, and what comes next anyway is questions from the book. You can check your answers. I recommend that you do one, check your answer, do another one, check your answer until you're getting the hang of it. There are some additional videos for you to watch if you need to hear it from somebody else's point of view. And we solved this question in class. So it's just recognizing that we can write a gradient as a ratio. And what that means is that for every 1 meter you go up, you have to go across 12. So our rise is equal to 1 and our run is equal to 12. And then from that we can draw the ramp and work out the distance from the points that we needed to. And again, we solved it in class. I'm happy to go through it again if you'd like, but you should have the solution. So just make sure you have a go. Remember that the more you practice, the better you will understand. And if you need help, come and see me.